Hey, some more trig graphs. Isn't this fun? I imagine a few people want to look at this question, right? I mean, look at these things here, though. Okay, so we've got our two trig graphs here. F of x, still find it's, I guess they have to. It's kind that they go f of x, there it is, there it is. So we said sometimes it's useful if you've got a highlighter and can highlight this. I didn't do too badly there. So f of x equals a cos b of x. So it's something related to cos. And let's just pause on that one. Cos x. What would the graph of y equals cos x look like? There it is. There's the cos graph, right? So there's our basic graph. And along with that, we need to ask ourselves, what is the effect of A and B? Now, we've done this in one of the previous questions. We're looking at A and B. I can't remember what number it was, but scroll up, have a look at a previous video. Maybe you did it already. So what does A do? If we multiply a function, so if we got like x squared and we said 7x squared, what's the effect of the number we multiply in front? It just stretches it out. So it stretches it from the origin and stretches it up and it stretches it down. Just stretches it further away. So we saw that in our parabolas where we had like y equals x squared and then it stretched, and you saw that y equals 2x squared. If that's 1, then it would stretch it up to 2. It stretched it out. Let's get rid of, where's my rubber here? So let's get rid of that there. Okay, so that's what the A does. What does the B do? Well, the B in this case, so if we multiply the x, that squeezes a few more in. So if we had that as cos x, and let's say we had 2 cos x, then we'd squeeze 2 of them in. See, it's like 1 back to the point, 2 again there. So like there and there again. Did I get 2 of them in there? Yeah, we got back to our starting point. Okay, so that's what the 2 does. Kind of squeezes it that way. It's kind of one way of looking at it, but actually it's making the period twice. What's the normal period of cos x? So this is 0. When does it start repeating itself? Well, at 360. What's the period? So this graph, when does it get back to it? What's the period of this graph? Well, 360, because look, from 90, so this whole distance here, this is 360. So the period hasn't changed. So actually, isn't B just 1? That is one of the easy ones to do. And A, how much have we stretched this out? So let's do it like this. How far have we stretched this out? Well, y equals cos x would normally go between -1 and 1. This one goes between -2 and 2. So isn't A just 2 because it's stretched it out? And then the C, last question, is what is the effect of C? What is the effect of adding over here? If you had our parabola, because we spend so much time on the parabola, I actually reference it to go, if we had y equals x squared, or if we had y equals x plus, let's say, 3 squared. Isn't this a horizontal translation or shift? So this moved the graph left or right. So if we had, let's compare these two, y equals x plus 3, well, that moved it left. Remember, it always felt like it did the opposite. Or -3, then it moved it right because it's moving it by that amount. That's, remember, it was like x minus p squared. Same idea here. It's going to move it left and right. Hasn't been stretched. Hasn't been translated up or down. Hasn't changed the period. So if you have in mind what y equals sine x looks like, then all you have to know is how much have we moved this graph? How much have we moved the graph? Well, here's our key bit of information. This part here is 0.5. When would this normally go through a half? Where's Brendan? Where are you? Yes. No. So when would it be a half? Well, let's just shift sine a half 30 degrees. So if we looked at y equals sine x, we know that it will go through 30 and a half. This one here goes through a half at 0, so it's moved left by 30 degrees. So therefore our C value must be 30 degrees because that's x plus 30. So x plus 30, remember it kind of feels like the opposite, so it's moved left by 30 because it says x plus 30. Okay, definitely that horizontal translation I think is the trickiest out of all of them compared to that, or if we had a plus q at the end. Okay, so we don't need that anymore. For which values of x between 0 and 270, let's just get rid of all of this stuff here. Goodbye. And as I once again talking in front, I've got the video, so all of this stuff you didn't see. Oh well. So for which values between 0 and 270, so just between here and here, that's where we're looking, is f of x times g of x less than or equal to 0. So f of x we've put in blue, so when you're multiplying the two graphs, so when you're multiplying that one, but we actually only care about between there and, what should we make the other one? Yellow. And g of x, so when you're multiplying them, it's less than or equal to 0. If you're multiplying two numbers and their product is negative, just look in positives and negatives, what do you know about those two numbers? Well, one must be positive and one must be negative, right? Because think of something, so you've got like a negative times a positive will give you a negative, or at 0. So let's see when that happens. So when are the signs of these graphs different? When is one positive and one negative? Doesn't matter which way around, or 0. So here, at this point, let's start at 0. Can you see both of them are positive? They're both above 0. So that's not going to work, not going to work, not going to work, not going to work. What about at this stage? This graph is 0, and this graph is positive. What's 0 times a positive? What's 0 times anything? Well, it's 0. So that's going to tick this criteria. What about if we look at these points here? So let's keep going and keep going. We've got a negative here because it's below the y-axis, and we've got a positive because it's above the y-axis. So a positive times a negative, well, that's also going to be less than 0. So that's good. So let's keep going. Let's keep going. Oh, something happens over here. So let's go up to that point. So up to here, well, this is still positive. This is negative. But clearly this, not an asymptote, just drawing a point here. This is interesting because at this stage, they both become negative. Negative, 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 negative. And that's not what we want. A negative times a negative is a positive. And then we keep going. Well, at this stage, this graph is 0. A 0 times a negative. So that's going to work. So we've got between 90 and that mystery value, including, and, or, not interested in ands and ors at the moment. Wasn't this at 270 and 270? Yeah. Or at x equals 270, and that's 0 and that's a negative. So you just need to work out what this mystery value is. I'll leave you to do some of the work. Determine, as a hint, just look at the sine x. How much has it moved left or right by? Because all you're interested in was what's the x-intercept of sine x here, or sine x plus 30. Determine the equation of h of x if the graph is reflected across the x-axis, then translated 40 to the right. So let's just see what each of these things does. Okay, reflected across the x-axis. If something is reflected about the x-axis, what do we do? If we had a happy parabola and then we reflected a made a sad parabola, what do we do? You just multiply it by -1. Okay, so multiply the whole thing by -1. And if it's translated 40 to the right, well, didn't we say that that bit in brackets, if it's going to the right, are we going to add or we're going to subtract 40 degrees? Well, to the right means that we're going to subtract 40 because it looks like it's gone, it looks like it's, what am I saying? It looks like it looks the opposite, right? So minus 40. Okay, so we got an x minus 40 and we're just going to multiply the whole thing by -1. And next question, next video, because it looks quite different.